Suppose Wolfman and Dracula are writing a paper together. They both want to edit the file at the same time. What should they do? They could take turns, but then they'd each spend a lot of time waiting. Or they could each work on their own copy at the same time and patch things up afterward. But stuff always winds up getting lost, overwritten, or duplicated, and nobody wants that. The right solution is to use a version control system. This keeps the master copy of the file in a repository located on a server, a computer that is never used directly by people, but only by the applications that serve them. No one ever edits the master copy directly. Instead, Wolfman and Dracula each have a working copy on their own computer. This lets them work independently, making whatever changes they want. As soon as Wolfman is ready to share his changes, he commits them to the repository. Dracula can then update his working copy to get those changes. And of course, when Dracula finishes working on something, he can commit, and then Wolfman can update. But what if Dracula and Wolfman make changes to the same part of their working copies? Old-fashioned version control systems prevented this from happening by locking the master copy. Only one person, or monster, could open the lock at a time. This guaranteed that two or more people could never accidentally make changes to the same file at the same time. But once again, that meant people had to take turns. Most of today's version control systems use a different strategy. In these systems, nothing is ever locked. Everyone is always allowed to edit their working copy. Sometimes, of course, people will make changes to the same part of the paper. If Wolfman updates the master copy first, his changes are simply copied to the repository. If Dracula now tries to commit something that would overwrite Wolfman's changes, the version control system stops him and marks the conflict. It's up to Dracula to edit the file to resolve the conflict. He can accept what Wolfman did, replace it with his own work, or write something new that combines the two. It's up to him. Once he has fixed things, he can go ahead and commit. Version control is better than mailing files back and forth for at least 3 reasons. First, it's hard, but not impossible, to accidentally overlook or overwrite someone's changes. The version control system highlights them for you automatically. Second, there are no arguments about whose copy is the most up-to-date. The master copy is. Third, nothing that is committed to version control is ever lost, which means it's like having an infinite undo in your editor. This works because the version control system never overwrites the master copy in the repository. Instead, every time someone commits a new version, it is saved on top of the previous one. Since all old versions are saved, it's always possible to go back in time to see exactly who wrote what on a particular day, or what version of a program was used to generate a particular set of results. Version control systems do have one important shortcoming. If you are working with plain text files, it's easy for the version control system to find and display differences and to help you merge them. Unfortunately, images, MP3s, PDFs, or Microsoft Word or Excel files aren't stored as text. They use specialized binary formats. Most version control systems don't know how to deal with these formats, so all they can say is, these files differ. The rest is up to you. This episode introduces the basic workflow you'll use when working with a version control system. To keep things simple, we'll assume that someone has already set up a repository for you. A later episode will show you how to do this yourself. Dracula and Wolfman have just been assigned to the Universal Monsters project and need to figure out where they should hide their secret lair. The Mummy has already put some notes in a version control repository on the universal.softwarecarpentry.org server. Its full URL is https://universal.softwarecarpentry.org/monsters. Every repository has an address like this that uniquely identifies the location of the master copy. It's Monday night. Dracula sits down at his computer and runs Smart SVN. This is a Subversion client, i.e. a program that runs on your machine and knows how to move files back and forth to a repository located on a server. There are lots of other graphical clients out there, and many power users run Subversion commands from the shell, but we'll use Smart SVN in this lecture. In order to create a working copy on his computer, Dracula has to check out the repository. He only has to do this once per project. Once he has a working copy, he can update it in place to get other people's work. Using SmartSVN, Dracula goes to the Project menu and selects Checkout. The dialog that appears on his screen has two required fields. The first is the URL of the repository, which tells Subversion where to look for the master copy. The second specifies where Dracula wants the working copy put on his computer. After filling them both in, he clicks. SmartSVN opens a connection to the server, checks that Dracula is allowed access to the repository, then creates a new directory on his computer and copies files into it. Once the checkout is complete, SVN makes a bookmark for the project. As in a standard file browser, double-clicking on this and on the directories inside it opens things up and displays their contents. Dracula can find out more about the history of the project using Subversion's log command. When he clicks on the log button, SmartSVN displays a summary of all the changes made to the project so far. This includes the revision number, the name of the person who made the change, the date the change was made, and whatever comment the user provided when the change was submitted. As you can see, the Monsters project is currently at revision 6, and all changes so far have been made by the mummy. While we have this dialog open, notice how detailed the comments on the updates are. Good comments are as important in version control as they are in coding, because without them, it can be very difficult to figure out who did what, when, and why. You can use comments like changed things or fixed it if you want, or even no comments at all, but you'll only be creating trouble for your future self. A couple of cubicles away, Wolfman also runs SmartSVN to check out a working copy of the repository. He also gets version 6, so the files on his machine are the same as the files on Dracula's. Unfortunately, he then has a bad hair episode and has to take a short break. While Wolfman is calming down, Dracula decides to add some information to the repository about Jupiter's moons. Using his favorite editor, he creates a file in the Jupiter directory called moons.txt and fills it with information about Io, Europa, Ganymede, and Callisto. After double-checking his data, he wants to commit the file to the repository so that everyone else on the project can see it. The first step is to add the file to his working copy. This isn't the same as creating it. Dracula has already done that. Instead, adding the file tells Subversion to start keeping track of changes to that file. It's quite common, particularly in programming projects, to have backup files or artifacts of compilation in a directory that aren't worth storing in the repository. This is why version control requires you to explicitly tell it which files are to be managed. Once he has told Subversion to add the file, Dracula can go ahead and commit his changes to the repository. He clicks Commit, adds a meaningful comment, and then clicks Continue. SmartSVN establishes a connection and copies his changes over to the master. The version number has now changed from 6 to 7. Notice that this version number applies to the whole repository, not just to the files that have changed. Version numbers always refer to snapshots of the entire repository. So if you say version 119 of a file, that is always going to be the same as version 119 of any other file or directory in the repository. The next morning, when he's back in human form, Wolfman starts work once again. He runs SmartSVN and does an update. SmartSVN tells him that a new file has been added to the repository, and Wolfman's working copy is now up to date with version 7, which is the current head or most recent revision. Looking in the new file, Jupiter/moons.txt, Wolfman notices that Dracula has misspelled Callisto. It's supposed to have 2 L's. Wolfman goes ahead and edits that line of the file. He also adds a line about Amalthea, which he thinks might be a good site for a secret lair, despite its small size. He then commits his changes to create version 8 of the repository. Later that night, when Dracula wakes up and starts working again, the first thing he wants to do is get Wolfman's changes. Before clicking Update, though, he clicks on the Log button to see who has done what. He's curious what Wolfman changed, so he selects moons.txt and asks SmartSVN to show him the changes. SmartSVN brings up a double-panel display that uses color to show insertions, changes, and deletions on a line-by-line basis. After checking them over, Dracula is satisfied, so he dismisses this view and does the update. This is a very common workflow. Check to see what has changed in the repository, check to see if it's going to get in your way, and if it's not, pull those changes down to your machine. It's worth noticing here how important Wolfman's comments about his changes were. It's hard to see the difference between Callisto with 1L and Callisto with 2, even if the line containing the differences has been highlighted. Without Wolfman's comments, Dracula might have wasted time wondering if there actually was a difference or not. In fact, Wolfman should probably have made 2 separate commits, since there's no logical connection between fixing a typo in Callisto's name and adding information about Amalthea to the same file. Just as a function or program should do one job, and one job only, a single commit to version control should have a single logical purpose, so that it's easier to find, understand, and if necessary undo later on. Hello, and welcome to the 3rd episode of the Software Carpentry lecture on version control. In this episode, we will show you what to do when your changes overlap with someone else's. This is probably the most important episode of this lecture, which is in turn one of the most important in this course, so we'll give you a quick preview of what we're going to do, then go through those steps using SmartSVN. At the end of our previous episode, Dracula and Wolfman had both synchronized their working copies of the monsters repository with the master, so that all 3 are at revision 8. Dracula edits his copy to change Amalthea's radius from a single number to a triple to reflect its irregular shape. Dracula then commits his changes, creating revision 9 of moons.txt in the repository. As he's doing this, Wolfman is editing his copy to add information about 2 other minor moons, Himalaya and Alara. A few minutes after Dracula's commit, Wolfman tries to commit his changes to the repository, but Subversion won't let him. Wolfman's changes were based on revision 8 of the file, but the repository is now at revision 9. Wolfman has to update his working copy to get Dracula's changes before he can commit his own. Luckily, Dracula edited a line that Wolfman didn't change, so Subversion can merge the differences automatically. This does not mean that Wolfman's changes have been committed to the repository. Subversion only does that when it's ordered to. Wolfman's changes are still in his working copy and only in his working copy. But since those changes are now based on the most recent revision in the repository, he can go ahead and commit them. Let's see that again in slow motion. Dracula opens moons.txt, changes Amalthea's radius, and then tells SmartSVN to commit his change. After entering a comment to describe his work, he clicks commit, and voila, the repository is at revision 9. Now it's Wolfman's turn. His edits are based on revision 8 because he hasn't done an update to get revision 9 yet. He adds 2 lines to the bottom of the file, saves his changes, and then tries to commit them. Everything is okay until he clicks the commit button, when Subversion tells him that his commit failed because his starting point is out of date. After doing an update, he asks SmartSVN to display the differences between his copy and the master. Since it merged Dracula's changes automatically, all Wolfman sees is the lines he added. He can now go ahead and commit his changes to create revision 10. Wolfman's working copy is now in sync with the master at revision 10, but Dracula's is one behind at revision 9. At this point, They both decide to add measurement units to the columns in moons.txt. For once, Wolfman is quicker off the mark. He adds a line to the file and commits it to create revision 11. While he is doing this, though, Dracula starts editing his copy. He also inserts a line at the top of the file, but not the same one as Wolfman. Once again, when Dracula tries to do a commit, Subversion tells him that he can't. This time, though, when Dracula does an update, he doesn't just get the 2 lines Wolfman added to create revision 10. There is an actual conflict in the file. Dracula has to edit his copy of the file to resolve the conflict. Once he is done, Subversion will let him commit to create revision 12. Let's watch it again. Wolfman opens moons.txt, inserts a line, and then commits his change. At the same time, Dracula opens the file, which is already out of date compared to the master copy, inserts a different line, and tries to commit. Subversion tells him he's not allowed, so he does an update. When it detects the conflict, Subversion creates 3 temporary files to help Dracula resolve it. The first is called moons.txt.r9. It is the file as it was in Dracula's local copy before he started making changes, i.e. the starting point for his work. The second file is moons.txt.r11. This is the most up-to-date revision from the repository that includes Wolfman's changes. The third temporary file is called moons.txt.mine. This is the file as it was in Dracula's working copy before he did the Subversion update. Finally, Subversion modifies the file in question, moons.txt, to show Dracula's changes and the changes from the repository side by side. Wherever there is a conflict, Subversion inserts a line of less than signs, .mine, followed by the lines from the local copy of the file. It then inserts a separator made of equal signs, followed by the lines from the repository file that are in conflict with that section, and puts a bunch of greater than signs, .r11, at the end. Some power users prefer to work with these interpolated changes directly, but for the rest of us, there are several tools for displaying diffs and helping merge them. If Dracula launches the one that's built into SmartSVN, it displays his file, the common base that he and Wolfman were working from, and Wolfman's file in a 3-pane view. He can use the buttons to pull changes from either of the edited versions into the common ancestor to merge changes, or edit the merge file directly. When he exits, Subversion marks the conflict as being resolved and deletes the temporary files it created. Dracula is now free to do his commit and create revision 12 of the repository. In this case, the conflict was small and easy to fix. However, if 2 or more people on a team are repeatedly creating conflicts for one another, it's usually a signal of deeper communication problems. Either they aren't talking as often as they should, or their responsibilities overlap. If used properly, the version control system can help the team find and fix these issues so they will be more productive in future.